In the last seconds of the last video, I had an error that when I was explaining about the carpets that are manufactured in quarter one but are sent to quarter two, I used the word transformed. Okay, sorry, it was slip of the tongue, and I wanted to say that they are transferred to that part. Okay, let's check the decision variables after all discussions that we have had together. Okay, these are decision variables, 7 decision variables, and as you can see, there are explanation about the two type of decision variables that you see over there. Okay, before we read them, so you see I have put the message also for you here about the word transform. I'm emphasizing on that because I don't want that you get that wrong impression when you are learning something for the first time. It is not transformed, it is transferred, exactly like the regular usage of transfer in regular English. And so remember that correction and never use transform again, like my mistake. Okay, so we have X15. As you can see, it says the amount of carpet produced in the first quarter, and the unit is a square yard. And this X15 is here. If we check this graph, you can find it on this part of the graph, and it says, and the 2 here is also a good guide for that, because it says production cost per square yard is 2, and when we check that table, you see it is only for quarter 1. So when we are talking about X15 is the amount of carpet produced in quarter 1. You may ask, Milad, how much of it going for the demand and how much it is going for the next quarter? We control these things by X56. As you can see here, X56, the amount of carpet that is produced in quarter 1 but transferred to quarter 2. So if X15 is 1000 and X16 is 500, so let me write them here so you can see them here. So for this example that we are doing, if X15 is 100, is 1000, and X56 is 500. Now you can answer that question. It means that in the first quarter, they have produced 1000 square yards of carpet, and 500 of them are transferred, are sent to quarter 2. So the remaining 500 are used for the demand for quarter 1. Okay, and the similar description for the everything. And as we can see, when you are doing or you are producing carpets in quarter 4, there is no next quarter to transfer this produced carpets there. And that's the reason that here we have X15, X56, and we have X26, X67, and 37, 78. But when here we have X48, there is no X89 because there is no next quarter. Okay, let's go to the next activity. It is asking you without formulation, just specify what is the objective function. Here, it is not asking you to do the formulation, just conceptually mention what is the objective function. For having a better answer for this, if you cannot remember it completely, go and check the case. I'm sure 100% you will find the answer. Okay, as it is mentioned clearly in the case description, the objective is to minimize the total production and inventory cost. So on one hand, first, you want to produce all the things that you need at the quarters that are cheapest, and also you are gonna keep those cheaply produced carpets for use in the coming quarters. So it is a combination of production and inventory problems. You want to minimize these two things while satisfying all the constraints. Okay, now write down the objective function. Here it means the main objective function that has the mathematical description formulation. Okay, let's check the objective function now. Okay, the objective function, since we have 7 decision variables, our objective function is composed of exactly 7 terms: 2x15, 5x26, and like that. And as you can see, 1, 2, 3, 4, 5, 6, 7. Okay, let's check it together. Of course, since we want to minimize the production and inventory cost, on one hand, we have the production cost that we want to minimize here. Oh, what happened? Okay, here we have the production cost, and here we have the inventory cost. The inventory cost for each unit of carpet is 25 cents, and the production cost is different. If you remember, we emphasized it when we were reviewing the case together, that different quarters impose different costs of production, but the inventory cost is per unit is fixed. So these 2x15, you can find it here, and 5x26, 5x26, 3x37, and 3x48. And for the inventory cost, the number of units that you send from quarter 1 to quarter 2, x56. The number of units that you send from quarter 2 to quarter 3, x67, and the number of units you send from quarter 3 to quarter 4, x78. All you have here, and now we are good with the objective function. And after the objective function, similar to the other network models, we are gonna have our constraints, and each node is associated with a constraint. And so far you have seen it is the dominant fact that each node corresponds to one constraint. The only time that we had violation of this rule to some extent was regarding the maximal flow problem, with all those things that we discussed together. Okay, write the constraints of the 4 supply nodes on the left. Why I'm asking you this activity without any explanation, because it has nothing new for you. There are just supply points, and we have had similar discussion with the supply chain models, with transportation models, with the transshipment models, let alone all the other network models that were also to some extent similar. Just consider the supply chain models that we had and write down the supply constraints that we have regarding this model. Let's check the answer now. I'm sure you have found the answers much easier than the previous one. The reason is that for the supply points that we have regarding this example, as you can see here, for example, with Q1, there is only one outflow. It is not, for example, like the examples we had with the supply chain model, that one plant supports several distribution centers. It is just sending its output to node 5. Okay, so the corresponding constraint would be very easy. It is just x15 that must be equal or smaller than 600, as you can see it here. X15 equal or smaller than 600. For Q2, 3, and 4, you should use the same logic to write these constraints. Again, the reason it is easier than the previous one that we had together is the fact that we have only one outflow from each supply node. Okay, after this set of constraints, let's go and write the constraints with the demand nodes that we have that are on the right. And remember, how many demand points do we have here? We have exactly 4 demand points for Q1, Q2, Q3, and Q4. But one point you need to consider for the first time is this fact that, for example, node 5 works as a demand point and also a transshipment node. It gets some of the input from node 1 and also send some of the carpets to the next quarter demand. Put a good time on this so you will enjoy the correct answer you get finally better. Okay, let's check the answer. I hope you have the right answer with you. Okay, so here are the constraints that you can see for demand points that we have. On one hand, because they are demand points, so on the right hand side we have all of them with equal sign and the demand amount. For example, for node 5 on the right we have 400 because it is a demand point. For all of the demand point we have had this before. And another point is the fact that it is a transshipment point, so the amount of inflow and outflow must be the same. So we have the constraint as this: x15 inflow and x56 outflow. Since one of them is inflow, the other one is outflow, so it is x15 minus x56 equal to 400. You can also write the constraints as this, because since it is a transshipment node, so the inflow must be equal to outflow. The inflow to node 5 is x15, as you can see here, and the outflow is x56 and 400. So these two things must be equal. Of course, this way of writing, as I have always told you, is more professional, but if you are more comfortable to write it like this is okay. The rest of the nodes are treated in the same way.